Alright, so in this video we're really looking at perimeter of rectangles, and they tell us that the rectangle pictured in a previous exercise, which is this one right here, has a perimeter of 70 feet. We want to make drawings of at least 3 other rectangles with a perimeter of 70 feet, so we're starting off simple. Here with perimeter, remember that if you're finding perimeter, what you're doing is find the distance of the perimeter around a shape, or the length around a shape. In this case, that means you're adding, right, the width, which is here, plus another width, plus a length, plus a length. So let's go back over that. That's width, plus length, plus length. Essentially, you're adding up all the sides. So in general, if we simplify this, 2w's, right, is 2w, plus 2l's is 2l. So perimeter equals this, which is 2w plus 2l. So we have this nice little formula to work with now, right? And here in this case, well, width was equal to 20, let's say, and length was equal to 15. Well, then the perimeter is 2 times, perimeter is 2 times the width, which is equal to 2 times 20, plus 2 times the length. The length is 15. You can see it working there. Well, then the perimeter equals 40 plus 30, which is 70. Now this process right here might seem a little bit redundant because we could just add the sides, like why are we doing all this extra stuff, but this will help us kind of formulate what's happening here as we look at other rectangles. So with other rectangles, let's say I make the width longer. So now the width is equal to, let's say I'll double it to 40. Well, can I do that? Well, the answer is no, because there are limits to the rectangles we can use, because here, if we have width equals 40, then 2w equals what? Well, then it equals 80. And we already exceeded the perimeter that we need of 70. So let's just backtrack and think, what is a reasonable high point for my width? And that's kind of fun to play with, but we'll kind of narrow it down here. Well, I know if the width is equal to, let's say, 34, then what? Well, then 2w equals 68. In that case, your length would equal what? Well, what's left over? Well, we need 70 in total, right? Minus what we have so far, 68. So now we're finding what 2 lengths would have to be equal to, right? Because we can just say, well, 1 length equals the difference. In fact, whatever's left over, in this case, 2, those 2 units have to be filled by the 2 legs of a rectangle. So we have this super, super long and skinny rectangle. You can imagine it would go right off the page. We're just scaling this thing down here. And we just set it up right here. So imagine it's a much longer rectangle. It's 68 units long and 2 feet. Excuse me, 1 foot. Let me do that again. So if 2 widths equals 68, how long is it? It's not 68 long, it's 34 long, sorry. The width is 34. Here, when I find 2w, that's just the sum of the top and bottom widths. And the height's just 1, right? It's 1 on each side. So it seems that in terms of whole numbers, the highest we can have for a width would be 34, because the length is then down to 1 whole unit. But just for fun, we can go a little bit further, right? The width could be, let's say, 34 and a half, couldn't it? Because if the width equals 34.5, it's a 4, right? Then what happens? Well, then 2 widths is equal to 30, well, this multiplies by 2, 34.5 times 2, which is what? Well, 69. And then what? Your length is equal to a half, right? So then what? Well, then 2 length is equal to 1. This time you get a longer rectangle, right? Just a little bit longer. 34.5, but now the length is a half. And this will still add up to 70. And you can keep going with this, kind of understand what's happening here. Let's say I wanted to sketch a last rectangle where the width is equal to what? Let's say 34.9. Well, then 2 widths is equal to what? Well, 68 and then 0.9 doubled, 69 point what? 0.8. Then what is the width equal? Well, 70 minus 69.8, which is equal to, sorry, this is 2 lengths, 0.2, which means what? Well, which means that 2 lengths is equal to 0.2, right? Okay, and each length is equal to 0.1. And we have our, let's say, our last rectangle for our sketch here. But look what's happening, right? This time the rectangle is what? 34.9 in width, and now it's only 0.1 in height. So there is a limit here. It seems that the width can never be larger. It can never be equal to 35. It has to be less than 35, right? Width has to be less than 35, but it has to be greater than 0, right? We can't have a negative width. And then if we look at it from that perspective, once we choose a width in this range, what does the length equal? Well, the length, or two lengths, right, is always equal to the entire perimeter 70 minus the width you've chosen, right? And it couldn't just be, by the way, it couldn't just be 2w, two widths. If you look at what we were doing so far, we pick a width, 34, let's go back, right? When the width was 34, well, what happened then? Well, two widths was 68, and we take two lengths is equal to 70 minus two widths, which is equal to 2. Here, when the width equals 34.5, right, we find two widths, which is right here, and then the length fills the remainder. So in this case, length is equal to 70 minus 69, which is equal to, so two lengths, equal to 1. Okay, and then we can cut that in half to find the length. And then here in the last one, the width is 34.9, and the two widths was 69.8. We want to find what's left over, and that's what two lengths is equal to. Essentially what you're doing in all of these is the same, right? If you think about the rectangle for a moment in a picture, what you do is you assign a value for this width right here. Okay, and we're trying to find our perimeter. Well, then we double it because this width should be the same. And then what's left? Well, this piece right here is left, and so is this one. That's two lengths. So once you pick this width right here, right, and you start with that, you double it to find two widths. So I'll write that again. That's two widths. Now the total perimeter is equal to, like we said before, two lengths and two widths. If you picked two widths already, what's left? Well, the two lengths need to be found. How do you do that? Well, you take the total perimeter, which in this case is 70, but you can generalize it even more. Total perimeter minus the two widths is equal to the two lengths. It's just kind of like an extension of this equation right here as a fact family. And this pattern will really help us understand this question, I think, in an intuitive way. So we've got this equation to work with. Anyway, so we actually answered a couple of questions there. We made our drawings of perimeters at 70 feet. And here they're kind of asked us to examine what is the width of a rectangle with a perimeter of 70 feet if its length is 1 foot, well, 2 feet, and L feet. So they're kind of asking us to look at it backwards. Well, that's kind of be the same thing, right? Here I think I have enough room. So now assuming that length is equal to 1 foot, what is the width? So that's kind of fun. We'll go backwards from what we were examining before. Well, the total perimeter P is equal to 70. And to get that, we double the length, right, 2L plus 2W, and that's how we get 70. So working backwards, the perimeter 70 minus 2L would equal 2W. I'm going to put this in parentheses. So if the length is equal to 1, right, that's what we have here, what's going to happen? We have 70 minus 2 times 1, or minus 2, and that equals 68. But that's equal to 2 of the sides, 2 of the widths, so 1 width would equal half that. 68 cut in half, which equals 34. If the length is equal to 2, which they ask next, well then you have 70 minus 4, and that equals 66. And then the width is equal to half that, or 33. If the length is equal to 3, well then you have 70 minus 6, which equals 64. And the width now equals what? Well, 32. Notice what just happened. We went, the width equals 34 when the length is 1. Then when the length is 2, you have a width of 33. Then when the length is 3, you have a width of 32. So you can kind of see what's happening here if we set up a table. And our two categories are length and width. Length and width. Kind of see this linear pattern. When the length is 1, your width is 34. But when the length is 2, your width is 33. When the length is 3, your width is 32. When the length is 4, you could predict that the width would be 31. So here, when you have L length, right, could extend this. What is the width always equal? So we want to know what is any width if you're given a length. You can see it here in the formula, but what's essentially happening if we break it down in terms of algebra, right? 2w plus 2l equals p. We want to know what does the width equal if you know your length. So we know that 2w equals p minus 2l, right? In other words, perimeter minus 2 lengths equals the 2 widths. And then you want to know what the width equals, so divide both sides by 2. You get w equals the perimeter minus 2l over 2. Okay, well in this case that equals what? Well, perimeter is 70, right? So 70 minus 2l over 2. Divide both pieces by 2, and you get 35 minus l. And that's essentially what you're seeing here, right? 35 minus l, right? So w will equal, because here we got 34 when l was 1. So you can imagine 35 minus 1 equals 34. 35 minus 2 equals 33. 35 minus 3 equals 32. 35 minus 4 equals 31, and so forth. And that's kind of the basic logic that the total, right, perimeter is 70. 35 always represents half your perimeter. Take one of the legs away, and you'll have the width. If you look at the picture up here, total perimeter is the square, right? Well, half perimeter, let's say, is this piece right here, and that piece. It's 35. A width plus a length is 35. Take away the length, right? This piece right here, and what's left is the width. So in terms of a picture, that's kind of what's happening. So we've actually almost finished this question now. Let's just look at it. We've answered kind of what's happening here, and we want to know what is the width of a rectangular perimeter if its length is half a foot or 3/2 of a foot. Well, we have our formula down here. We can plug that in, kind of extend the table. Let's say the length is equal to half. Well, then the width would equal, right down here, 35 minus a half, which is equal to 34.5, right? And then if the length is equal to 3/2, right, dot dot dot, 3/2, well then the width is equal to 35 minus 3/2, which is equal to 33 and a half, right? So we can just formulate in this way to see what's happening. Got that? Give the dimensions of rectangles with perimeters of 70 feet and length to width ratios of 3 to 4, 4 to 5, and 1 to 1. We can get back to that. But we know, because you already answered E and F. Suppose the perimeter remains at 70 feet. How does the width change if we're increasing the length? Well, the width decreases as the length is being increased, which you can kind of see here. Right? If we increase the length, here 1, 2, 3, 4, the width is decreasing each time if the perimeter remains at 70. Okay, so make a graph with the width and length, and focus on pairs of perimeter of 70 feet. How does your graph illustrate your answer for part E? Okay, so in other words, they want us to graph the values in this table right here in a meaningful way. So basically we're going to use this table to set up a quick graph. Now the width will be our dependent variable, that's depending on what we're selecting for the length, and the length is the independent variable here. That's how I'm setting it up. You could reverse it if you thought about it in a different way, but since we're using length to determine width, make length your independent variable, and make width your independent variable. So length, we're just going 1, 2, 3, 4, right? That's what we have here in this table. And for width, we have 34 all the way down to 31. So here, what I'm going to do is go by 5s. So we have 5, 10, 15, 20, 25, 30, and 35. Although the problem here is that all of my y values to fit within this little chunk right here, so maybe I'll choose a different interval. I don't want to crunch them up like that. Instead of by 5, let's go by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and then 32 and 34. A little bit more room. But here, again, you only need 2 points to really determine a line, but I want to plot these points to show you what's happening. We have 134 to begin, so this will be right here. Then 233, maybe about here. then 332 right there, and 431 right there. So what we have here is a linear function, right? Oops, wrong tool. That's decreasing over time. In other words, as the length is increasing, like we said before, you can see the width is getting less and less and less as the graph is extending here. So we do have a linear function that we can see happening here in this graph. So the basic logic here is that if I add up half the perimeter, I get what? I get 35, right? So that means that the length and the width, if I add them up, just one side each, I'm always going to get 35, half the perimeter, right? Let's say we have length and width. Here we don't know what the exact lengths and widths are, we just know that if we reduce them, in the first case we get a 3 to 4 ratio, which you can see here, we have what? We have 15 to 20. If you divide both of those by 5, you do get 3 to 4. But how would you figure that out if you didn't have it here in the diagram? Well, what I would do is I'd say, okay, my length, let's say I can think of it as 3 times something, some scale factor. And the width is then going to be what? Well, it's in a ratio of 3 to 4, so it's going to be 4 times an equal scale factor. Right? We scale both of them up some amount of times. 3 to 4, in this case, is being scaled by 5, because 3 times 5 and 4 times 5 gives you 15 and 20, but you're going to solve that. So 3x plus 4x equals 35. Combine these two, we get 7x equals 35. Solve for x by dividing by 7 on both sides, we get x equals 5. Now we can use that then to find your length and width, right? Because that's what we're doing here, given the dimensions. So you would take your length is equal to 3x, so x is 5, 3 times x is 15. That's what we have here for our length. And the width is equal to 4x, which is equal to 4 times 5, or 20. Now that's just going into some of the background to solve this. Here, if we have a ratio of 4 to 5 now, length to width, we can do the same thing. So we have 4x plus 5x equals 35. Here we get 9x equals 35, and then x equals 35 divided by 9, right? Now 9 goes into 35 how many times? Well, 9 times what is 35? Well, it's 9 times 4 is 36, too large. It's 9 times 3 is 27. It has a remainder there of 8, so 8 ninths. So about 3.8 repeating, right? So here 3.8 repeating, multiply it by 4, and that is your length. 3.8 repeating times 4 equals your length, and your width is equal to 3.8 repeating times 5. And that seems terrible at first, but remember, here we have 3.8 repeating as a fraction, 35 over 9. So let's just do that. So for length, we get what? 35 ninths times 4. And that equals what? Well, 35 times 4 is 120, plus 20 is 140 over 9. And then the width is equal to, scroll down, width is going to be equal to 35 ninths times 5. What does that equal? Well, then the width equals 150 plus 25, 175 over 9. So now we have length is equal to 140 over 9, and width is equal to 175 over 9. You can do the long division, or at this point maybe you want to just kind of break out the calculator. So we have 140 divided by 9, but 15.5 repeating, so 15.5 repeating, and then 175 divided by 9, that equals 19.4 repeating. So here we get an approximate length and width with that ratio. But we were able to do it because we understood this simple pattern here. Now what about a 1-to-1 ratio? Length to width is equal to, change colors here, 1 to 1. Okay, well, if it's a 1-to-1, we just get this situation, which is length plus width equals 35. So it's just x, right, plus x equals 35. So that means what? Well, we have 2x is now equal to 35, right? And in other words, length and width are equal. And divided by 2, and x equals what? Well, 17.5. So each side is about 17.5, and that was certainly a lot easier to deal with than the last one. Alright, well I hope this helped.